Lesson 5-4, Solving Inequalities. When you add or subtract the same number from each side of an inequality, the inequality remains true. So for example, if our original inequality is 5 is less than 9, if you add 4 to both sides, you get 9 is less than 13. Well, since we added the same number to both sides, the inequality is still true. It doesn't change the inequality. It might change the numbers, but the inequality is still true. So let's take a look at this example and how we can solve this. So we have x plus 5 is greater than 7. So just like we did when we were solving equations, you're going to subtract 5 from both sides. So x is greater than 7. So we have figured out that x is greater than 7. So now we want to replace the x with any number that's greater than 7. But it cannot include 7 because our inequality is not greater than or equal to, it's greater than 7. So let's use the number 9. So if we replaced 9 for x, we get 9 plus 5 is greater than 12. 9 plus 5 is 14, and 14 is in fact greater than 12. So that would be true. So you would give your answer is x is greater than 7. Pause the video to try a few examples below. So for the first example, y plus 10 is less than 3. If we subtract 10 from both sides, we get y is less than negative 7. So if we picked any number that is less than negative 7 and we plugged it in, it should make this stand true. So a number that's less than negative 7 would be negative 11 plus 10 is less than 3. Negative 11 plus 10 is negative 1 is less than 3, and it checks out. So my answer is y is less than negative 7. The next example is x plus 7 is greater than or equal to 10. So I'm going to subtract 7 from both sides. So x is greater than or equal to 3. So for this one, you could actually plug in 3 and see if it's true. 3 plus 7 is greater than or equal to 10. 7 plus 3 is 10, is greater than or equal to 10, and it's true because 10 is equal to 10. So when we are graphing the solution of an inequality, you first want to make it where the variable is on the left. So if we're looking at this example here, 3 is greater than or equal to g plus 7. So let's solve it first. So we subtract 7 from both sides, and we get negative 4 is greater than or equal to g, which is also written as g is less than or equal to negative 4. So now to graph this, since it's including the negative 4, including the negative 4, then we know that we're going to have a solid dot above the negative 4. So I'm just going to draw my negative 4. I'm going to put a solid dot over the negative 4 because it's including it, and then it wants all the numbers less than negative 4. So all the numbers less than negative 4, that would make this stand true. So now if we picked a number and we went back and checked, we should be able to pick any of the numbers over that are underneath of here. So let's pick negative 8. So if we go back and we plug in negative 8 for g, we are left with 3 is greater than or equal to negative 1, and that would stand true. So this would be your graph. When you multiply each side of an inequality by the same positive number, the inequality remains true. So if we have negative 6 is less than 10, if you multiplied both sides by 2, you would get negative 12 is less than 20, and that stands true. When you multiply or divide each side of an inequality by the same negative number, the inequality symbol must be reversed or flipped for the inequality to remain true. So in this equation, we have negative 5x is less than 45. So if we had this as an equation, you would first divide both sides by negative 5 because you're trying to solve for x. Well, anytime that you multiply or divide by a negative, you have to flip the sign. So it's x, and then this sign gets flipped to be greater than a negative 9. So now your answer is x is greater than negative 9. Pause the video to complete the lesson review. The two inequalities on the left, you're just solving the inequalities. The inequality on the right, I want you to solve and graph the inequality. Make sure you show me this lesson review for verification of this video.